Welcome. Today we'll be configuring a PLX51 HART-4i gateway, a 4-channel HART interface for HART field input devices to connect to a level sensor on a HART network. With this PLX51, you can convert up to 4 analog signals on a HART network to either EtherNet IP, Modbus TCP, or DNP3 TCP UDP. This video will also apply to the PLX51 HART-4o for use with HART field output devices, such as a valve positioner. So over the course of the video, we'll cover downloading the configuration utility software, as well as the DTM pack for PLX50 and the HART-4i sample project for Logix. We'll create a new project for our gateway in the PLX50 config utility. We'll go over the communication parameters for EIP, Modbus, and DNP3 networks. We'll take a look at the sample project in RS Logix 5000. And finally, we'll go over the status and diagnostic data that we can see once the module is online. Let's begin. To perform the first-time configuration of the module, we'll use the PLX50 configuration utility software, which is available from the ProSoft technology website. You should download and install it if you haven't already. And while you're there, also grab the sample project for Logix as well as the DTM pack. We'll be using them both a little later on. Once you open up PLX50 configuration utility, start by creating a new project. The first time you connect the PLX51 to your network, you'll need to launch the DHCP server and assign it an IP address on your subnet. So you can go to Tools in the menu bar and select DHCP server, or just click this button here in the menu bar. In the server window that comes up, it should recognize that there is a ProSoft technology device that is requesting an IP address. And there is our gateway. Click Assign, and on the window that opens, you can enter the IP that you want the module to use and click OK. So by checking Enable Static, you will disable DHCP and set this address as permanent so that it won't disappear the next time the module is power cycled. Once you're connected, the line for the module in the DHCP server window should turn green. We can close this window. Now note, when you're doing this, you should be sure that there isn't another DHCP server on your network that you're connecting to, because it might assign an IP address to the module before you've had a chance to discover it here. Next, right-click on the new project and select Add. Select the HART-4i or 4o if that's what you have. And here we see our basic configuration screen. We have a general tab for our network configurations and then 4 channel tabs. And these are where we configure each channel, as you would guess. So we'll enter an instance name for the module. For the IP address, you can just click the Browse button to the right of the address field to bring up the target browser where you can see all the PLX50 gateways on your network. Select your HART module. It'll have the IP address that you just assigned. Click OK and the IP will appear in the address field. Under Protocol, we can select what communication interface we want to use. If you select EtherNet IP, you have the option of setting up a Logix path for accessing advanced diagnostics from the HART field device. I'll do that by clicking the Browse button and selecting my Control Logix processor. Moving on, each channel has a range of basic configuration options for how the module will interface with the respective HART channel. So on each tab, there is a checkbox to enable the channel. Under Signal, you can choose a range of 4 to 20 or 0 to 20 milliamps. The 0 to 20 is a general non-HART enabled range that you can use if you need to. There is also a checkbox to enable HART under HART communication that you can deselect if you're trying to get readings from a non-HART analog device. So back under Signal, there's also a raw, min, and max values, as well as filter settings and an engineering units max and min. And you would use this to scale the raw analog input. So moving down to configuration, The PV update rate set how fast the process variables for devices must be updated. There are a range of time intervals, and fast here simply means the module will update as fast as it can. Some processes don't require that they be monitored with great frequency, and by setting a lower update rate, you can give yourself more bandwidth on the HART network. Relay messages, class 2, here refers to messages from the Logix processor or DTM. And you can allow the module to schedule those messages in between PV extraction or not. And fixed HART address is for setting up multi-drop applications, which is a bit more advanced, but something you can do. And under trends, we can select a source to determine what sort of data should be logged for this channel. There is a selection of different analog variables to choose from, and you can see raw analog current is one of the options for a non-HART device. The sample rate controls how often the data is logged. You can choose every second or something more like every minute or hour, depending on the requirements of your application. Now, if you are setting up a HART for output, there is an additional section for fail mode where you can configure what the module should do if communication with the field device or the Logix controller is lost. Program fault freeze only applies if you're using the EtherNet IP interface, and enabling it will freeze the output analog value to its last state in the event that the controller enters a faulted or program mode. Unchecking it will force the output to the fail value under the same circumstances. And you set the fail value right here. And this is in engineering units. COM fail freeze is the same sort of function, but it applies to losing the connection with the field device. Checking it will freeze the output at its last state before communication was lost. Unchecking it will force it to the fail value that you set here. The timeout is where you set how long the module should wait before deeming communication with the field device to be lost. So, moving back to the 4i, next to each of the channel configuration tabs, there's a tab for advanced diagnostics. This allows you access to parameters for your devices that might not be accessible through normal HART commands in the control system. Parameters like uptime on a device or other diagnostic data that might allow you to better optimize your process. To set this up, you just enter a name for the parameter that you want to include in your Logix program. Then you would build a HART command by clicking the Build button here. In the window that opens, we have our description and diagnostic type. Under the HART command section, we have a field for the command number. You should refer to the user manual for the pertinent field device. And usually it will have a section that says HART command 50 gives you the following parameter. Then moving down, you can specify what data type it should extract and where that data lives in your field device by setting the result offset. So if you wanted to extract a value from word address 2 in your field device, this will tell it to go read from address number 2 and then place it into a specific Logix tag. So I'll click OK, and next I'll browse for that specific Logix tag by clicking the Browse button here. And this will list all the available tags in the Logix controller that we established a path to previously under the General tab. So what you would do is just create an appropriate tag in your program and then select it here. Once this mapping is applied, the HART command will be read and it will update the tag in Logix without any other coding or logic. And it will do so at the rate specified in the configuration. And you can set up as many of these as you need. The last tab is for DNP3 configuration. This only becomes available if you select DNP3 as your protocol under the General tab. Everything here is for secure authentication. For example, there's a feature where a DNP3 slave will want to authenticate that the master it's communicating with is the correct one. All of these settings would generally be driven by the DNP3 master. typically a SCADA, and you would just match these settings to what's been implemented there. To do this, you would enable security, and for key change method, the module only supports pre-shared keys, meaning each device on the network needs to have its own key. The MAC algorithm is where you select what encryption algorithm to use to authenticate the master. The key wrap algorithm determines how keys are exchanged. I'll also point out that a security key can be created in ProSoft configuration tool. You can only do this, however, in the status form once we're online. So we'll come back to this a little later. So we should be ready to download the configuration to the module and go online. Once that is complete, we can move on to Logix Designer or RS Logix 5000. I'm using the sample project available from the PLX51 product page. There should also be a ladder file available soon if you wanted to add the HART-4i to an existing project. The PLX51 comes with an embedded EDS file that you can install in RS Links. The same file is also available from the product page. And once the EDS is installed, you can simply add a new module under the EtherNet bridge, filter by vendor, select ProSoft, and the HART-4i or 4o will be right there. Then you just give the module a name and enter an IP address and you're done. Now, if you're running a version of Logix prior to 20, you'll have to add the PLX50 as a generic Ethernet module. And in that case, you would use the following connection parameters. Getting back to the sample project, the HART-4i is already added under Ethernet connections, and we have the HART-4 routine, as well as all the UDTs that are used. If you then open up the controller tags, you can see what the tag assembly looks like. We have diagnostic data that is mapped to fixed locations. You can see the user manual for specifics. We have module configuration data, Modbus statistics, process variables, device status, etc. An important feature for the PLX51 is the ability to configure any field device with data type managers, or DTMs. Both the 4i and 4o have DTMs that can be used in any FDT frame. So to use DTMs with the PLX51, you'll need to download and install the DTM pack configuration software from the ProSoft website. This contains a communication DTM and a gateway DTM. So you just run the installer. Then when you update your FDT catalog, you should be able to bring in the PLX51. And once you've done that, you should be able to connect drivers supplied by the manufacturers to parameterize, detail, and configure your field devices with the easy-to-use graphic interface of your FDT of choice. And once you're online, receiving data from your field device, there is a plethora of diagnostic and status data available back in the configuration builder. In the tree view, you can right-click on the module and select My HART Status from the menu. In the status window, there's a general tab with the basic configuration and status info for the module. The rest of the tabs will be dependent on what interface you're using. For Ethernet IP, we have communication statistics for that protocol, and this includes timeouts for Class 1 and Class 3, as well as connection counts. If you selected DNP3 as your interface, you would have the DNP3 statistic tab instead. You would also have a security statistics tab for DNP3 with security and authentication statistics. Down at the end, the DNP3 security tab is where you can generate or download a key for the DNP3 master authentication. This key will be used only if security authentication has been enabled back in the module configuration. Now, once you're online, you can generate a new key by clicking the button here. This new key will appear in the field, and you should write it down or copy it and then download it to the DNP3 master. Or if the master already has a key, you would type or copy and paste it into the field and then download it by clicking this button. Either way, the module and the master must share the same key. Note that once you close this window, you won't be able to see this key again. It's a security thing, so make sure you write it down before moving on. If you chose Modbus for your interface, obviously you will see Modbus communication statistics. You can also select the status for each channel. This is more detailed. There are quite a few tabs, each with information about the specific field device on this channel and our communications with it. On the General tab, it will tell you if the device is, in fact, connected on the HART network. We also have the basic information about that specific device. We're not going to go over everything. Some of these are fairly self-explanatory, others are a bit more advanced. The Device Info tab has more information about the field device. This is extracted from the device on startup. Device status has a range of general conditions and alerts for the module. And there is also a HART status section with some COM information. We'll take a closer look at the PV tracking. This shows the current, the minimum, and the maximum values of the process variables that the module has captured. And this can be a nice way to get a quick overview of the range of values that you're getting on a process, whether or not there have been any aberrations over time. We'll also take a look at the Diagnostics Trend tab. And here you can track a specific variable from your field device with a simple graph function. You simply select the source, and then you can adjust the sample rate and the minimum and maximum values displayed. It can also be set to auto refresh, or you can do it manually. And that should do it. If all the configuration information was entered properly, your PLX51 HART module should be gathering all the requested data from your HART field devices. If you have any questions or would like more information about the PLX51 HART 4i and 4o, use the link in the description to go to its product page, or feel free to give us a call. And if you found this video helpful, please give it a like. And if you're interested in more training and educational videos about industrial communication gear and technology, subscribe to our channel. Happy training!